Today we'll be exploring the controversial and highly debated field of forensic optography. Can the last image seen by a murder victim truly be captured on their retina, or is this idea nothing more than a macabre myth? Let's delve into the history, science, and cases that have sparked this debate. The concept of forensic optography, or the idea that the last image seen by a deceased person can be retrieved from their retina, dates back centuries. The earliest known reference to this idea can be traced to the Roman philosopher Pliny the Elder in his work Natural History. However, it wasn't until the 19th century that this idea gained traction as a possible forensic tool. In the 1820s, English scientist John Herschel hypothesized that the retina could retain an image even after the removal of the eye. Another researcher, Franz Christian Ball, discovered the light-sensitive protein rhodopsin in 1876. These discoveries and hypotheses laid the groundwork for the German physiologist Wilhelm Kuhne's experiments and the subsequent attempts to use forensic optography in criminal investigations. In the late 1800s, Kuhne conducted a series of experiments on rabbits, suggesting that the retina could indeed capture and retain an image after death. This idea was put to the test in a real-life criminal investigation in 1880, when optograms were taken from the eyes of a murder victim in Germany. While the images were inconclusive, they sparked interest in the potential of forensic optography. The science behind optography is rooted in the biochemistry of the retina, the light-sensitive tissue at the back of the eye. The retina contains a protein called rhodopsin, which is responsible for detecting light and transmitting signals to the brain. When exposed to light, rhodopsin undergoes a chemical change, and it's this change that forms the basis for optography. In theory, if the retina could be quickly removed and preserved after death, an image might be retrievable. However, there are several factors that make this highly unlikely. First, rhodopsin undergoes rapid decay after death, making it difficult to capture an image before it degrades. Second, the process of extracting the retina is extremely delicate and requires specialized equipment, which is often not available at a crime scene. Finally, even if an image could be captured, it would likely be distorted and lack detail, making it difficult to interpret. To better understand the science behind optography, let's delve deeper into the biochemistry of the retina and the process of image formation. As mentioned earlier, the retina contains the protein rhodopsin, which is crucial for detecting light and transmitting signals to the brain. When exposed to light, rhodopsin undergoes a process called photoisomerization, where it changes from its inactive form, cisretinal, to its active form, transretinal. This chemical change triggers a cascade of reactions called the phototransduction pathway, which converts the light signal into an electrical signal that can be processed by the brain. Once the light stimulus is removed, rhodopsin returns to its inactive form through a process called photobleaching. This cycle of activation and deactivation is crucial for maintaining visual sensitivity in various lighting conditions. Theoretically, if the retina were to be rapidly removed and preserved after death, an image might be retrievable based on the distribution of the active and inactive forms of rhodopsin. However, as mentioned previously, there are numerous factors that make this highly unlikely, including the rapid decay of rhodopsin, the delicate nature of the extraction process, and the distortion of the image due to the complex neural processing involved in visual perception. Despite these limitations, there have been a few cases throughout history in which forensic optography was attempted. We imagine that all of these cases will be from the 19th century, but surprisingly, this isn't actually so. Perhaps the most well-known case involving forensic optography is the 1888 murder of Mary Jane Kelly, one of Jack the Ripper's victims. Although there is no concrete evidence to support the claim, it is rumored that investigators attempted to use optography in their search for the elusive killer. However, due to the limitations of the technique and the lack of proper equipment at the time, it is highly unlikely that any meaningful information was obtained from the victim's retina. In the early 20th century, English author Sir Arthur Conan Doyle referenced the concept of optography in his Sherlock Holmes story, The Adventure of the Cardboard Box. While this is a fictional example, it demonstrates the fascination with the idea and its potential application in criminal investigations. In 1924, during the investigation of the Hinterkaifeck murders in Germany, investigators considered the possibility of using optography to gain clues about the perpetrator. However, they ultimately decided against it due to the state of decomposition of the victims' bodies. In 1987, the Soviet newspaper Pravda reported that forensic optography was used in a murder investigation in the USSR. According to the report, the optogram revealed the image of the killer's face, leading to his arrest. However, the validity of this claim is highly questionable, and no corroborating evidence has been found. More recently, forensic optography was attempted in the case of the murder of Maria Ladenberger in Freiburg, Germany in 2016. Investigators attempted to retrieve an optogram from the victim's eye, but were ultimately unsuccessful. While these cases demonstrate attempts to apply forensic optography in criminal investigations, they also highlight the numerous challenges and inconsistencies associated with the technique. No case has ever provided definitive, verifiable evidence that the last image seen by a deceased person can be captured from their retina. As we've discussed, there are several factors that cast doubt on the validity of forensic optography. Recent scientific research further emphasizes the challenges and limitations associated with this technique. For instance, a 2013 study conducted by Dr. Andreas and his team from the Institute of Legal Medicine and Forensic Sciences in Berlin found no evidence to support the idea that optograms can be retrieved from human retinas. Their research concluded that the rapid decay of rhodopsin after death, combined with post-mortem changes in the retina, make it nearly impossible to obtain an optogram with sufficient detail for forensic purposes. Studies have shown that rhodopsin begins to break down within minutes of death, and its concentration decreases significantly within just a few hours. This rapid decay makes it extremely difficult to capture a clear and stable image from the retina before the rhodopsin has degraded. Additionally, a study published in the Journal of Forensic Sciences in 2011 found that the concept of forensic optography is based on a misunderstanding of the retinal image formation process. The authors argue that the complex neural processing involved in visual perception makes it unlikely that a clear identifiable image could be preserved on the retina after death. The process of extracting the retina is extremely delicate and requires specialized equipment, which is often not available at a crime scene. Furthermore, improper handling of the eye can lead to damage, compromising the integrity of any potential optogram. After death, the retina undergoes several changes, including swelling and disintegration of retinal cells. These changes further complicate the retrieval of an optogram and contribute to the poor quality of any images that may be obtained. While Kuhne's experiments on rabbits show some promise, further research on animals has demonstrated limited success in obtaining optograms. These results suggest that the technique may not be as effective as once believed, even under controlled laboratory conditions. So, can the last image seen by a murder victim truly be captured on their retina? Based on the available scientific evidence and the history of unsuccessful attempts, it appears that forensic optography remains a myth rather than a viable forensic tool. While it may continue to capture the imagination, it's important to recognize its limitations and focus on the development of more reliable and scientifically valid methods in forensic science. We hope you enjoyed this in-depth look at forensic optography and its role in criminal investigations. If you found this topic interesting, don't forget to let others know about our exclusive Patreon content. Until next time, stay curious and keep questioning.